Hi everyone, this is Mythri. Welcome back to my YouTube channel. Now I am here to explain a small topic in EPC, Electronic Principles and Circuits. I have chosen a topic RC oscillator. Types of RC oscillator. There are several types of RC oscillator, including wind bridge oscillator, space shift oscillator, and twin T oscillator. Each type has its own advantages and disadvantages and is suitable for different applications. The choice of oscillator type depends on the factors such as frequency stability, simplicity, and cost. And linear electronic oscillator circuit that has produced a sine wave formula F is equals to 1 by 2 pi root 6 RC Windbridge oscillator. The Windbridge oscillator is a popular type of oscillator that uses an operational amplifier and a frequency selective network. It is commonly used for audio frequency applications and it has good frequency stability. The frequency of oscillator can be adjusted by varying the values of resistors and the capacitors in the network. As shown in the figure, F is equals to 1 by pi RC. R1 is equals to R2 is equals to R. Capacitor C1 is equals to C2 is equal to C. Resistor R1 is equals to R2 is equals to R. Space shift oscillator. The space shift oscillator uses a cascade network of RC space shifts section to provide the necessary space shift for oscillation. It is commonly used for frequency generation in the audio range. The frequency of oscillation is determined by values of resistors and the capacitors in the space shift network. The space shift network is shown in the figure. Twin T oscillator. The twin T oscillator is a type of RC oscillator that uses a twin T network which consists of resistors and the capacitors to generate the oscillations. It is commonly used in audio and low frequency applications. The frequency of oscillation can be adjusted by varying the values of resistors and the capacitors in the twin T network. Advantages of RC oscillators. RC oscillators are the simple and the cost effective compared to other type of oscillators. They can be easily integrated into an electronic circuit due to their simplicity. RC oscillator can be generate the stable and the accurate oscillations in the wide range of frequencies. Disadvantages of RC oscillator. RC oscillator may not be provide the high frequency stability compared to other type of oscillators. They may be sensitive to temperature variation which can be affect the frequency of oscillations. RC oscillators may require the careful component selections to achieve the desired performance. Applications of RC oscillator. RC oscillator are commonly used in the audio applications such as tone generation and the audio signals processing. They are also used in the timing circuits, frequency modulation, and the frequency synthesis. RC oscillator finds the application in various electronic devices, including the radio, television, and the computer systems. Frequency stability in the RC oscillations. The frequency stability of an RC oscillator depends on the frequency such as component tolerance, temperature variation, and the aging effects. To improve the frequency stability, precision components and the temperature comp- compensation techniques can be employed. Careful, careful design and the component selection are struggle for achieving the desired frequency stability in the RC oscillations. Design consideration for RC oscillators. The choice of the choice of resistor and the capacitor in the oscillator circuit affects the frequency of oscillations. The component tolerance should be considered to ensure the desired performance. The powerful supply voltage and the temperature range also impact the oscillator performance and stability. Circuit diagram of RC oscillator. A typical RC oscillator circuit consists of resistor, capacitor, and an amplifier. The feedback network and the frequency selective network are key components in this circuit. The value of the resistor and the capacitor can be adjusted to achieve the desired frequency of oscillation. Practical implementation of RC oscillators. RC oscillator can be implemented using the discrete component or integrated circuits. Integrated circuit oscillator offer advantages such as compact size, improved stability, and easy to use. Discrete component oscillators are allow for greater flexibility and customization. Troubleshooting and issues. Issues in the RC oscillator include the frequency drift, poor stability, and unwanted harmonics. Troubleshooting technique involves the checking components values, connections, and the power supply voltages. Adjusting the components values or replacing the faults components can be help resolve the issues in the RC oscillators. Frequency tuning and modulation in the RC oscillators. The frequency of oscillation in the RC oscillators can be turned by varying the values of resistors and the capacitors. The frequency modulation can be achieved by modulating the resistance or capacitance in the RC oscillator circuit. Such turning and modulation techniques allow for versatile application of RC oscillators. Comparison with other oscillator type. RC oscillator are the simple and more cost effective compared to other type of oscillators such as critical oscillator or the voltage control oscillators. Critical oscillators are offer a higher frequency stability but are more complex and expensive. Voltage controlled oscillator provide the frequency modulation compatibility but may require additional component and control security. That's all about this topic. Thank you.